Hi, this is your Dr. Bitla Venu. In this session, we will see some of the examples on isometric views. In our last session and before last session also, we have seen the examples for the isometric views. But in this session also, we will take few more examples other than the previous sessions. We will draw the isometric views. Now, let me move further to see the parts. So this is what one problem, and front view and top view of an object are given. Draw its isometrically. This is what the problem. The figure that you can see here, the height is 50 and it is the base is in L shape. The width and of the L shape is 20. Of course, we have some uh, gap here, that is 25, 25. Okay. So with this, and it is also having apex, but the apex is not exactly at the center. It is exactly on the vertical line. Okay. So with this, we need to draw the isometric view. Now, to draw this, we need to first draw the base first. Then we need to locate the apex. Then join apex with the bottom points. That means from the base points, draw the base, then locate the points of the base, then locate the apex, then join base points and as well as apex will gives us the isometric view of this figure. Now let us construct the base first. As you are aware that, so construct a rhombus with the given dimensions. Okay. Then after constructing the rhombus, you are aware that this is 25 and 25. So you construct this 25, 25. So construct a rhombus of side 45 and 45, as you can see here, 45. And here we have 25, 25 rhombus here, that we don't have any shape here. So after that, then name the point, and this will become our O point. Then locate the height, that is 50 mm, draw a vertical line of length 50 mm. Then join the points, the base end points with the height, the topmost point of the height, then which gives us the isometric view of this projections, orthographic projections. You can see here, this is the front view and this will be the top view. The problem is very simple, right? But it looks like complex, but the problem is very simple. You can see that first we have to construct the base, then locate the apex, then join the apex point with all the base points, gives us the isometric view of the figure. Now I repeat this once again. Then as you can see here, 20, 25, 45 and 45 with 45, 45 with 45 as side and construct the rhombus. Then we have some portion which is not having any material here. The side of that is 25. So with that, you construct one more rhombus at this corner. Then locate the apex point. From this location, the height of this apex from the backward corner is 50, as you can see here. This will be the front and this will be the back side, and from this point it is 50 millimeters. You can locate the top point first, then join the uh, bottom face corners with the apex point like this, which gives us the isometric view of the given orthographic projections. It is just similar to the some portion, I mean 1/4 portion of the square pyramid is not having some material. As you can see here, we have some void here. So that void, that gap is 1/4 of the square pyramid that you can see here. So delete this. Exactly, you can analyze what is the material now. So okay, now let me take one more example here. The front view and top view of an object are given. Draw its isometric view. Okay, then as you can see here, we have a rectangular plate 70 and 30. The height is 10. First we need to construct that. Okay, then first construct the bottom plate with 70 mm length and 30 mm depth, and height is 10 like this. After constructing the plate of 70 by 30 by 10, then we need to construct the portion that is having above the rectangular plate like this. Okay, so draw a line at a distance of overall length is 30, and at the mid we have 20, so that it is 5 and 5. So at a distance of 5, so draw a construction line. So the length of that is 40 here. Length of this line is 40, and from this corner, that is at a distance of 5. As you can see here, it is 30, and at the mid of this plate we have 20, some projection here. So now it is 5 for a length of 40. Draw a line which is parallel to these two lines. Then construct the rectangle 40 and 20 like this. Okay. Then after constructing 40 and 20 rhombus here, then locate a midpoint here. Locate a midpoint which is at a height of 70, as you can see here. Then after drawing a line for a height of 70 millimeters, then join this corner, and all the corners of the rhombus which we have drawn on the plate. Then draw an inclined line and join all those corners like this. Then join these two corners, maybe. Yes. But here we have some slot, so that we are not going to join these two corners. Then draw a line like this, that is 35 mm. And from this corner also draw a line which is parallel to this line, 35 millimeters. Then join these two end points like this. Then draw a corner point like this. Then draw one more point like this, which gives us the isometric view of the given figure for the given projections. As you can see here, we have a projection here, and on which also we have some slot. So all the dimensions are given to us. First we need to construct a plate with the given dimensions, then construct the projection, and on which we need to show the slot also. The depth of the slot is 35 millimeters. Let me repeat this once again, and these are the views, orthographic views given to us. Then construct the plate of 70, 30 with height 10, as you can see here. Then on the top of the rectangular plate, we have one projection here, and on which we have some slot. Okay, so with 40 and 20, construct a rhombus on this plate like this, and on this side, and draw a vertical line for a length of 70 millimeters. Then join all the points, end point of this line to the corners of this rhombus like this. Okay, then at the middle of this projection also we have some slot, as you can see here. From the top view you can observe that there is some slot for a certain depth. That depth is 35, as you can see here. Then construct the slot with the given dimensions. The width is 10 and the width, this width is 10, and this is 20 and this is 10. Then draw a line which is parallel to these lines. Then draw a line which is parallel to this line. Okay, this gives us the isometric view of the given orthographic projections. Okay. Now let me move forward to see and one more figure. As you can see here, the front view, top view and side view of an object are given. Draw its isometric view. Now, as you can see here, the front view, side view and top view all are same. Okay, then construct a bar, a square bar for this length. Then in the front view, side view and top view, the shape is same. Okay, then on all the sides we have the projections like this, 4 sides. At the mid we have some square bar, square cross-sectional bar, and all the sides of this bar also we have the projections like this. So with the given dimensions and construct or project the square bar like this, then as you can see, so draw all the lines like this. Okay, so this is what the figure, and then darken all these lines like this, dark all these lines like this, we will get the shape. Okay, so the height of all these, and the shape is 30 30. This height is 30, bottom height is also 30, and left side, right side and everywhere it is 30, 30 and 10. With the given dimensions we are constructed a shape which is similar in front view, side view and top view, and all the 3 shapes are identical. As you can see here, this is front view, side view and top view, and all these are identical. Now let me take one more problem here. Front view, top view and side view of an objects are given and draw the isometric view. As you can see here, even in this case also the front view, side view and top view is also same. As you can see here, front view, side view and top view is also same. For this figure we need to draw the isometric view. Now first observe the figure, and all the sides we have this depression. As you can see here, we have the depression of 10 millimeters and the height of the depression is 40, as you can see here. Then the all the sides are 60, as you can see here. Okay, we have a cube. On the cube of the sides of the on the each face of the cube there is a depression of 40 by 10, 40 by 10 depth. And now construct rhombus with 60 60, or construct a cube of 60 60. On each face we need to construct the depression of 40 and 10. Now you can see here, so this is 60, now this will be the 40, so that it will be 10 and 10, as you can see here. So 10 10, so that means on each face construct a rhombus of 40, side 40. Okay, now you can see here, this is 40 40 and 40. On each face we need to construct the rhombus, that is 40 40 40, as you can see here. On each face I have constructed a rhombus, and similarly, and that rhombus, on each rhombus of each face, then the depth is 10, as you can see here. Okay, so from the each corner, whatever the faces are visible, then show all those faces like this. Okay, so now construct the depressions like this. So you will get a corner here, you will get a corner here, and you will get a corner here. Then this will become the front view and isometric view of the front view of the given front view, side view, and top. As you can see here, each face is having the depression of 40 and depth is 10 millimeters, as you can see here. Okay. Now let me move further to take one more problem. Okay. So we have now, as of now, you have seen we have depression, but here we have the projection. As you can see here, you have a cube. In this case also front view, side view, and top view is also similar, but in the previous problem each face is having depression of 40 and depth 10, but now it is the projection of 40 and 10. Okay, as you can see here, the length of the cube is 60 and each face of this cube is having the projection of 40 and 10. Okay, so now let construct that. Now construct the cube of 60 like this. On each face construct the rhombus like this, but in the previous case we got the depression, means this will come inside the cube, but now it will be the projection, so this will be above the each face of the same dimensions, as you can see here. Now come to any of the face like this and construct the rhombus, then project all the sides like this. This is very simple, as you can see here. So now this will be the isometric view of the given three views, which are similar, as you can see here. The front view, side view, and top view is similar in this case. Now let me take one more problem. First, let me take one more problem. Here you have a problem. Steps, I think. It is front view, top view, and side view of an object are given. Draw the isometric view, as you can see here. Now construct, locate the corner point, and you consider one face. I'm considering this face. I'm constructing this face first. Okay. So each step is having 20, 20, 20, and this will become 20. And it is also moving. Width is 20, height is 20. Now move 20 and 20, 20 and 20 like this. And similarly, you can also move 20. And also, because it is having 3 steps, and move parallel to this also 10. Now close this end and as well as this line. Now draw the lines which are parallel to this line like this. Now draw the lines which are parallel to line like this. And then now construct this first, otherwise, and the length is 50, and from here you take 50 mm length, then draw the height which is for a length of 60, then the width is also 60, as you can see here, and join this corner and this. Now join this is how much is 20, and this length is also 20, and come down for a length of 40, of course. Then now draw a line like this, then draw a line like this, and from all these corners draw the lines like this, parallel lines. Now join this point and come down here, then come parallel to this line, then come down like this, then connect these 2 points, will gives us the steps problem. Now I repeat this problem once again, and first construct the side view, okay, and front view first, and this is the front view where I'm constructing. So take a point, and this point I'm assuming as O, and I'm moving from this point, and 20, 20, 20, 20 and 20. So now I move to 20 and backward 20, this 20 and this 20 is similar, and this 20 and this height is similar. Then go back, it is 20 and it is also 20. Now move up, and this height and this height. Now, and this length is also 20, then join this end point and draw a line parallel to this line, which will intersect at a point, and this will become the front view. Now, after joining this, and locate the height first and this length, so that is 60. So from O, locate a point on the construction line for a length of 60 and move up for a length of 60 also. Now draw a line which is 50 mm. Of course, it is 60 mm. Of course, this is 60. This will be 60, and this will be 60, and this will be 50. As you can see, 60 and 50. Now join this corner, and this corner like this. Then draw the lines which are parallel to this line. Otherwise, you draw a line parallel to this, then come down for a length of 40, then join this point and this point. And similarly, and draw a line which is parallel to this, and all the lines from the corners like this, then come down, then join this line, then come down, then join these 2 points, will give us the steps of the orthographic projection. The orthographic projections are given, but we have drawn the isometric view like this. Now let me take one more problem first, and we have a problem like this. Then first we need to construct the front view. As you can see here, I'm located a point, I draw a line and I locate a point and move up. This is 20. So move up from this point to it is 20. This length is 60. From here to here it is 60. The height is 50, as you can see here. This is 50. So now it is 50. Then this width is 60, as you can see here, 60, 60. And all the lines are 60 here because we are constructed this portion and this portion. Then we need to project, so that is 60, 60, 60 like this. Then join this and then come down, this point and this point join, and this point and this point you can join. Then also you can come down and join these 2 points. So exactly at this location at a certain height, or you assume that it is a mid of this shape. So there is a square bar projecting from this face for a side of 30. So as you can see here, the length of this square bar is 40. The side is also 30, side 30. So now after drawing 30, 30, 30, then draw a line, draw the lines. So one each parallel to these lines. So for a length of 40, as you can see here. Then fit a corner, fit a rhombus here, it looks like this. Then erase all the lines which are not visible in isometric view like this, then complete the figure like this. Now take one more problem here. Now let me construct this, then construct the plate for a length of 80 and height is 10. Then on the top of this plate there is one cylinder, and that cylinder is connected to the plate at one end like this. Okay. So after constructing the cylinder, so with the usual procedure, as you're aware that with the given diameter, construct a rhombus on the plate and construct one more rhombus at a height of 40, then construct the ellipse here and construct one more ellipse on the surface of this plate, join the tangents of the ellipse like this. Now there is one more web here, as you can see here, exactly at the mid, and you locate midpoint here and locate midpoint here, construct the web, and you also indicate the edge here and also indicate edge here like this. So now arrange whatever the lines which are not visible in the three-dimensional view. It looks like this. Now let me move further. This is one more figure, as you can see here. Construct the rectangle with the given dimensions, and 150, this will be 100 and this will be 50, height is 10. Construct a plate first, then the corner is as an ellipse, because in this case it is showing like a circular arc, but now it is not the circle. Then construct this arc and this arc using the ellipse standard procedure, ellipse standard procedure. Okay. Then after constructing this here, then join all the points like this. Now at the back top corner, there is one projection here, and on that also the projection height is 40. The length is also 40. At the mid of this projection, there is one cylindrical portion, as you can see here. So join all the points like this, then construct a rib here, which is in L shape, as you can see here. Then project downwards like this. Okay, and this will be. And the next is that we need to construct this cylindrical shape, right? And exactly locate the cylindrical portion. And also we need to draw the circle like this. This is a hole for a radius of 30. For a radius of, this is radius 30, and this will be the diameter 20, as you can see here, radius 10. But here also we need to construct the depression, that is the diameter is 30, as you can see here. So at all these corners you construct the ellipse like this, then remove all the unnecessary lines, then whatever the lines are visible, and draw all those lines like this. So this will become the isometric view. Now let me take one more problem here, and front view, top view and an object are given. Draw its projections. Now first construct the cylindrical portion on the top, and draw a rhombus for 60, 60, 60. Then after drawing or constructing the plate like this, and on the top, so there is, and this will become the circular plate, and come down like this, and also construct one more ellipse at the bottom, then join the lines which are not visible. On the top, construct one more rhombus with 30 mm length, because the one of the cylindrical surface is also placed on this cylindrical surface, so that you need to construct one rhombus here, and from all the corners of the rhombus, and move upwards for a length of 50. This length is 50, this length is 50. So on the top, construct an ellipse, okay, and on the bottom of also construct an ellipse, then join the tangents like this, which gives us a cylindrical portion is placed on a circular plate. It looks like this, but in this circular plate there is one slot, as you can see here, 10 rectangular slot, as you can see here. And also construct the top, and also construct one ellipse, then join these two circles with the tangent like this, then construct the slot like this. Okay, so this is what the given figure. Now let me go back what we are discussed as of now, and this is the cylindrical surface, cylindrical plate on which one cylindrical portion is located. Then after, one frustum of the cone is located. So the views are given here, and for that we have drawn the isometric view. In this case, we are constructed the cylindrical portion or the circular plate first for a depth of 10, and on the exactly at the mid of this circular plate there is one more cylindrical portion. So with the given dimensions, construct the cylindrical portion first. Forget about this slot, and later we can construct the slot. And on the top also there is one conical portion, that is frustum of the cone that you can see here. So with the given dimensions, we are constructed the cylindrical, conical like this, but at the mid of this section, so we have one slot here, as you can see here, 10. So next figure we are discussed is one rectangular plate on which we have one L shape, and this L shape is attached to the shape like this. Okay. Now let me take one more example that we are discussed as of now. As you can see here, first construct a plate, and on which we need to construct the cylindrical portion with the given dimensions and location. Then after constructing the cylindrical portion and as well as the plate, join this cylindrical portion and as well as the bottom portion with a web like this. And all the dimensions are given with the given dimensions. So join with cylindrical portion, rectangular portion with a web like this.